And next is our final fireside chat of the day, the promises and failures of 5G. It's important to look at everything, isn't it? So let's welcome our guests. They are Steven Carlini, Vice President of Innovation and Data Center at Schneider Electric, and Andres Vasquez, Global Segment Director, also at Schneider Electric. Welcome to you both. How are you?
Hey, good afternoon.
Yes, thanks for having me.
Good to see you both. Thank you very much indeed for joining us here. There's a lot for us to get through in the next 20 minutes, so let's push on. Because this fireside, we are very much looking at both sides of the coin here, the things that are working, the things that might not be working. But for you, let's start with some of the challenges. What are the main challenges that have hindered the widespread adoption of 5G technology so far? And Steven, I'll start with you if I can.
Great. So everyone was very excited about 5G for the last decade or so. It was supposed to be the next great thing, and we, as a data center equipment provider, were very excited because a lot of the rollout of higher band 5G was going to be dependent on edge data centers. So 5G, from a problematic perspective, everybody knows, propagation losses, complexity, unsightly equipment that was, installed that were, that looked dangerous. There was rumors that 5G was, tied to COVID somehow. There were all kinds of regulatory and permitting problems, but the biggest issue, of course, was why does the world need 5G? What is the application that's going to drive this investment in these data centers and the bandwidth and all the towers? So, again, 5G was one of the few generations that was broken up into three distinct types of deployments. You had the low band, you had the mid band, and for lack of a better word, the high band, or the millimeter wave, or the standalone 5G, or people are calling it 5G plus. So the other thing that was interesting that happened was all the initial rollouts of 5G were at low band, and they were actually lower performance than people were expecting, and lower performance than even their existing 4G. So lots of issues, but there is a bright side of this. It is still in the works, and we'll talk about that as we go through.
Yeah. So let me complement that answer then. So this is something that everybody is talking about for the last couple of years, as everybody is aware, and there are already people talking about 6G indeed. And as Steven mentioned, it's not only about the communication kind of technology, because there are several different technologies. 5G for sure is the nemesis of this transformation and evolution for the digital era. This is not a question about it. What I believe is, and we were discussing about it a couple of times, is that this is not being fully adopted or fully deployed for several reasons. One is the cost, for sure. Who will be paid for all these investments in order to upgrade every single platform? But we need to also be focused on, there are different type of 5G deployments. So the public 5G, let's say the one that we use as a in our smartphones and things like that, it is something that is being deployed. Most of the telcos are already deploying that. The evolution of the network is there. They are already deploying everything already in a virtualizer and cloud type of developments. But at the same time, since not every single device is ready, that's one of the biggest problems that we are noticing. So we're working with a couple of players, and even internally, we already deploy a couple of cases. So for me, it's more like the biggest stopper today is for cost, for sure, the complexity for private 5G. Not everybody really believes that all the orchestration and different platforms can be supported. The operational performance from the legacy OT and the way that they are thinking, how I plan to compromise my own security and the security of my data going to the cloud, those type of things. And we are focused on the edge type of computing that need to be processed and where that computing power need to be deploy it and who will be owning that type of facilities, as Steven mentioned. So for us, is we have a lot of on-prem deployment with private 5G. This is starting to happen. The lack of deployment or the impact on the deployment is potentially mainly addressed by the lack of sensors that are 5G enabled. And the other big question that everybody's asking for is, why 5G if I can do this already with 4G or with other type of technologies in my own factory? Those are the type of challenges that we're noticing, and the top reasons to invest are there. So how I can overcome in this legacy infrastructure and the technical debt that most of the companies already have. So I believe that those are the main reasons to invest, and we are seeing now big discussions around what are the killer applications and what are the game, how we can really gain the real-time data access that everybody's asking for, how we can deploy ultra-low latency communication, how we can deploy real machine-to-machine communication. Those are the real drivers for 5G and 6G and the next generation of computing. I believe that addresses the first question for the panel, and we will keep talking about potentials. Back to you.
That's exactly where I wanted to take things next, the question of the killer application, the thing that tips the balance between people questioning the cost or against the performance. Do you feel we're at that point now, or is there still a little way to go for some sectors?
Yeah, we're seeing some very, very innovative deployments. You know, a lot of proof of concept was done in stadiums, and if you have ever been in a stadium that had 5G, it's just amazing. You could do instant replays from 20 different angles. You know, you could order everything. You don't have to leave your seat. Manufacturing sites, and Andres was mentioning, you know, robotic process automation and tying all the systems together with 5G. And a lot of people talk in manufacturing, they talk about maintenance and using high definition video cameras. And that's certainly, you know, one of the initial applications that we're seeing. We're seeing airports. A lot of airports are benefiting from high band 5G. Shipyards. Another one, the recent Olympics in China actually had some of the trains going from the different venues, and they were having just the clearest and most believable high definition. They were saying it was almost holographic types of meetings they were having, because 5G was deployed, you know, through the entire route of these trains. So, you know, the applications are starting to happen wherever there's massive congestion or where there's, you know, a need for very, very high definition 8K and 4K video in the application.
Yeah, I agree. So in terms of, as we were discussing before, so if we isolate the two types of use cases, the consumer use cases in stadiums and all the smart applications with high definition video and even virtual reality, augmented reality kind of solutions, this is something that is starting to happen. The main challenge that we're seeing and the successful cases that we're seeing are happening at the industry side or even at the commercial side, where they are trying to deploy this type of technology. And that's why we're noticing a couple of companies are starting with their own private 5G deployments. So successful cases that we can share in the automotive industry, we're already working a couple of cases like that in order to manage automatic guided vehicles. It is a case of an automaker that is already building the cars in their production system. They're already embedded the 5G, and the car literally goes out after finish the assembly, driving by itself in a 5G network to the parking lot to charge and then to be distributed to the final dealer. This is something that is actually happening. It's not science fiction. We are seeing those type of use cases. The challenge that we see is that, as I said, most of the different use cases for this machine-to-machine interaction totally depends on the devices that we want to connect. Even in our own factory, we already announced, it's not a secret, we already announced a couple of proof of concept in our own factories with different service providers in France, here in North America, And we have successful histories with different use cases that we can share with video analytics, with artificial intelligence also embedded in our own factory with our EcoStructure platform. And those are there. The challenges that the team are sharing with us is exactly that. So not all the legacy applications or sensors that everybody has in the market are ready to do that. And we're not talking only about the specific sensor that you have in the factory. We're talking about the autonomous cars, for example, and things like that. Yes, autonomous robots in the factory. So those are the type of things that we can share. We are also working and seeing the value of the 5G replacing fiber, for example, at the production lines, where we are already working on replacing our fiber optic interconnectivity in one of the assembly lines. Because of the vibration, we noticed that the fiber broke, so you can't replace it by 5G. You have a benefit using it. So there are several use cases. We have it fully documented, and the challenges are there. I believe that this is a matter of time in order to enable all these use cases in the market and in the different industries.
Yeah, very exciting use cases as well. A question I would have, though, is as adoption and transformation grows exponentially, if it keeps rolling at the pace it's starting to and is, how much pressure is there going to be to make sure there is the capacity within data centers, for example, within the networks, to make sure it can keep up with that growth? Is that something that would ever make you nervous, or do you feel there's the strength in the industry to keep pace and stay ahead of that curve?
Yeah, that's a great question, and right now there's a tremendous amount of focus on data center capacity and network capacity because everybody is so excited about AI and deploying AI, developing these large language models and deploying them, and we've been talking and deploying a lot of solutions. And if the supply chain was there for the H100 chips, and the supply chain was there for some of the longer lead time items in data centers, we'd have the capacity now because there's definitely the demand. So there is a huge pipeline of data center capacity that's going to be coming online. One of the barriers also is utility power. So utility power has to keep up with the data center demand, and that's one of the issues besides the GPU chips. But the other piece of the equation is the high capacity networks. So as AI becomes more multimodal, and it's not just text anymore, and ChatGPT-4 is actually one of the first multimodal AIs. It takes images and it takes videos. So it inputs that media, but it also outputs that media. So when you're inputting, high definition videos through 4K and 8K, you're going to need number one, high capacity network, and number two, local edge type of data center, because you don't want to send that much data to core data centers thousands of kilometers away. So the capacity is definitely at the core being developed, but at the edge there's also a big push to develop the capacity for AI or edge AI. And with that, because I talked about earlier that one of the costs associated with high band 5G was going to be the local data centers. So 5G could be an application running in these edge AI data centers. So it all kind of coming together, at the edge, with the computing capacity and the controls for 5G and AI at the edge. So it's really, really interesting time.
Yeah, I agree. And part of the key differentiator that we're noticing is all this cloudification of the market and the idea that you can run in one single server in a virtualized environment all the network orchestration as is happening today. And we are noticing how the telcos are evolving in order to also support different end user applications in the same physical infrastructure, looking to address the ultra reliable, lower latency kind of applications. So this is an evolution. What we're seeing here is a new ecosystem, let's say, that need to be developed and deployed. So that's why we see this as local data centers or on-prem data centers, which is actually happening, owned by the end users for most of the private 5G use cases. We are also seeing network edge data centers owned and operated by service providers, and the traditional colo and big master hyperscale data centers. All of that will be running that killer application on AI kind of application. Gen AI for sure is the case. And we are already noticing that all that lower latencies can only be addressed with local computing. So that's why we're seeing telcos and service providers, colo players going after this brand new space, let's say, which is as close as possible to the user, not necessarily on-prem, or even on-prem, but owned and operated by a service provider with managed services and a brand new type of application. So those are the type of things that we're seeing. And this is the only way that this can be sustainable. We can let you know that we have a recent white paper on AI. This is something that we invite you to also download from our website. And we recently also announced a couple of new applications that are already available in order to address your physical infrastructure at the edge. So with that, I think that we can invite everyone to just follow up in our posts and our different social media accounts in order to follow up what is happening, because it's a lot of things happening. And right now it's a very exciting opportunity for the different players in the ecosystem to go after this specific space.
Yep, tremendous amount of excitement, and yeah, well worth seeking out that white paper as well. We are basically up to time, I would say, gents. So I'd like to thank you so much for your time, for the benefit of your experience. Really enjoyed your company this afternoon.
Thank you so much.
Thanks for having me.
Thank you very much indeed. Take care, guys. Thank you.